Perfect. Okay, thanks so much. Yep, so can you hear me fine? Yep, okay, cool, thank you. So yeah, I'm Diana Todea, I'm an SRE with Elastic, and today I'm going to be speaking about SLOs, namely Serverless Observability, a case study of SLOs. So first of all, I would like to introduce a bit further about myself. So I work in observability team, and today what I'm going to be speaking about is a project that we've been involved since day one at Elastic, meaning that our team as SREs collaborated a lot with the developers while we basically created this feature called SLOs, which is something new in the observability stack. So you can check my LinkedIn profile, and also in the GitHub repo there are the slides from today, so you can already download them if you want to. Right, some fun facts about me. I live in Valencia, Spain. I speak 5 languages, and I just cut my hair today, like before coming to the conference, just, to mess with people. And yeah, that's about it. So let's go to the context of this talk today. So why basically Elastic started to use the SLO, and why we're thinking that this is a cool feature is basically that in the last year or so, right now, Elastic has been transitioning to serverless. By serverless, I mean Kubernetes. And yeah, during this quite big of a transition, like you all imagine, like with big companies, we've seen like a lot of changes in the observability stack, and how we wanted to like get more proactive insights when dealing with multiple cloud providers in multiple regions, and also something that could support our famous cross-cluster search, which is like basically the federated search queries along all the configured remote clusters. So that's kind of like how it all came to shape. In the past, we were using SLIs, so service level indicators, in the form of watchers that basically alerted us. But yeah, we wanted something, let's say, a bit more robust, a bit more proactive, that could also be integrated with the alerting and the observability stack in general. So this is how everything came like into creation, and so we started to collaborate with the project managers and the developers. So yeah, let's start digging into. So there are like a few definitions here I would just like to recap, because they are very basic, but they are very, very important in today's talk. So many of you probably you work in observability, you are also SREs, and like we deal on a daily basis with SLAs. SLA, like with the service level agreements, that's more like on the sales user type of level. And also with the SLOs, the service level objectives, which are the goals, right? The service level provider goal to defend the SLA and achieve happy users. So that happens at the level of SREs and product. And the service level indicators, basically there are these metric used to measure performance. And that's like, let's say, at the level of the devs, developers, and SREs. While we are thinking also in the terms of SLOs, we're also trying to make a point of the burn rate alerts. So that comes really useful when we think about the rates at which we are burning the error budget over a defined period of time. And we cannot really have it without the error budget, which is the service, defined as 100% minus the SLO. So these are like some basic definitions just to keep in mind going further. So at Elastic, historically, so we differentiate between two types of methods of manipulating data. So in the past, we had this method called rollup historical data, which is now deprecated, that basically summarized and stored historical data for later analysis. Nowadays, we are using transforms that are based in machine learning, which are slightly more, let's say, efficient because they can scale really well and they are converting existing Elasticsearch indices into summarized indices. So couple of, this distinction is quite important because transforms are really like the core, how everything, that sustain SLOs. So we'll see that in the next slides. So what are transforms doing? Well, you can use transform to pivot the data into entity-centric indices that summarize the behavior of users or sessions or other entities in the data. Or we can use transforms to find the latest document among all the documents that have a certain unique key. Right, so when can we use these transforms? Well, there are typically three situations that we can use them in. We can use them when we want to create the summary tables to optimize queries, or when we need a complete feature index rather than a top-end set of items, or when we need to sort aggregation results by a pipeline aggregation. So don't worry, I'll get into more, let's say, use cases later in a demo. Right, so basically how everything is architectured, it's, like I said, the SLO service is founded on the transform service that is used to roll up the source data into roll-up indices. So what happens under the hood is that the SLO service rolls up the data to a single document every minute, and then computes a summary document based on the SLO definition and these roll-up documents. So what happens is that because we are using this intermediate layer and we are not relying on the raw data, then we can compute the SLO data faster with less storage. So basically this type of architecture really blends with the use case we have at Elastic. Being, we deal with a lot of cloud providers and also like with multiple regions. So it's really important to understand a bit more how this is structured. Right, so I've been mentioning that the SLOs are part of the observability stack. So basically, the whole idea of the SLO was introduced to be used by SREs, right? So to be very, very blended with our daily work, that could help us, proactively, basically, in our troubleshooting cases and so on. So for us, it's a proactive and strategic approach to monitor and maintain the service level objectives and the SLA. And also acts as a communication layer with a common language to align across teams. So it's very useful for us, for example, if we want to communicate with other teams, other engineering teams, or even with managers. So let's say if we want to see like, okay, what's like in general, within a dashboard, how are we doing in a specific, for a specific application, or, like in general for interval of time, this is very handy to communicate with other teams. Right, so talking about good versus bad SLOs, how we normally differentiate between these. So normally a bad SLO is something really vague that is not, quantified properly, lacks metrics, lacks undefined, lacks a threshold, basically, has no observation window. So you don't want to have that. You want to have like a good SLO that's very, very focused on, it's achievable, right? So it's focused, it's very specific, it's measurable, and you want to have it well defined in that sense. So when defining these SLOs, basically we are aiming at answering kind of like 4 type of questions, more or less, that could help us within observability. So we wanted to ask, like, to answer the questions like, okay, is my service fast enough? Or is my service available? Is my service accurate? Or also my service is at the capacity? So we thought about the SLO methodology that could use basically a standard, right, for observability. And also could help us in our work within reliability, within incident management. Right, so a priori we used very few service level indicators, very few types, and this changed nowadays. So at the moment we are using around 5 types of service level indicators. The ones that are more important are the APM latency and availability, the custom metrics, the custom query, the histogram, time slice metrics, and the synthetics. The synthetics one is not available at the moment. It will be released quite soon. But I wanted to put it there because it's also like a very good use case that will be very handy for SREs. Right, so I'll just briefly describe what's synthetics SLI about. So basically, this type of service level indicator provides metrics for availability and latency that can be used to monitor services that don't have access to other application logs, metrics, or traces. Right, and right now I'm just going to show you some, these are examples from the actual production environment that we have been working on, so that's just like a real life example. But anyway, I wanted to just like briefly describe each type. So the APM latency SLI is an SLI focused solely on APM data, so on APM failed transaction rate. And it could be something like, for example, 99% of transactions occur under 100 milliseconds, or anyway, the threshold that you want. You can group it by a specific filter. So you have there, for example, transaction name, but you can, choose whatever you want, like deployment ID and so on. You can have the query filter that you're interested in, and obviously select the transaction name and service environment. Right, the APM availability SLI is something quite similar. It focuses the same on APM data and works with APM transaction latency. So for example, you can measure something like 99% of transactions that are being successful. The histogram metric SLI will be something a bit more complicated or complex. Will be useful for storing pre-aggregated high-resolution data with minimal footprint. So you can have something like 99% of events have a latency between, specific thresholds, minimum and maximum. And yeah, it could look something like in this particular example here. The custom metric SLI is something that it's an SLI that works with metrics. So works with metric fields and uses a sum aggregation and supports basic math and Boolean logic between multiple fields. And it could be something like 99% of accepted events have been processed. The time slice metric SLI basically kind of like deals with logs, metric traces, and also supports like a lot of aggregations. So you have like, for example, average, min, max, cardinality, last value, standard deviation, percentiles, and document count. And because of the type of this SLI, basically you are forced to use a time slice budgeting method. We'll see it a bit later. Right, so as I was showing in the previous slides, there was like a group by field there at every definition of the SLO. So what does that mean? Basically, when you are grouping by a specific field, then we'll create multiple SLO within one definition. And that will give you, the granularity to check, for example, an SLO for, let's say, each service, each handling cluster or each project ID, so you can check exactly a specific instance of an SLO. Right. Also, the purpose of using the SLO was to use it with infrastructure as code and with APIs. So that's why, well, basically the whole logic there behind was to use it with for developers. You can manage it using the APIs, you can create them, update them, etc. You can integrate it with the GitHub, so it's namely aimed to be used by developers. Right, so once we create a service level objective, we can also define as burn rate alerting. What does that mean? That once we have that specific alert, we can calculate the rate at which the SLOs are failing over multiple windows of time. Right? It's good because it will give us more or less an indication like how the service is degrading, and it helps prioritize multiple issues at the same time. Right, so let's see how it works. It will work with multiple windows, like I said. For each severity, we have two windows, like the short and the long window. The short window is 1/12 of the long window. So when the burn rate alert for both of these windows will gonna be exceeded, then the alert is triggered. Right, so the good part about using a burn rate alert is that we'll reduce alert fatigue, we'll have like improved user experience and a good precision. So how the burn rate alert within Elasticsearch has been defined, has like four severities, like low, medium, high, and critical. But this can be adjusted as you want. So it depends on the notification strategy that you have at your organization. They can be modified. They can be like, if you want to keep like only low and critical, then you could do that. So it's quite customizable in that sense. Right, so for example, we created the burn rate alerts. We integrate them with a specific connector, like for example here with Slack. And then we'll receive a bunch of alerts in production, for example. So you'll receive like in this basic default definition, we'll receive like 4 of them. So according to the severity level, and then you can go ahead and check the burn rates alerts, like the history, to take a more look at the SLO, how it evolved over time. This how are correlating between each other. Right, so right now I've been talking a lot about theory. That's not my favorite part. This is my favorite part, the demo. So, sorry. Yeah. So here, basically we are looking at the transforms in the stack management. So like I said, we need to create the transforms first to be able to use SLOs. So we create the transforms, and then we can obviously view a bit more details about them, like messages, the health status. We can go ahead, in the specific panel, we can actually start to troubleshoot or reset a transform if we want to, if we have any desire to do that. So once we have this transform, we can go ahead in the observability stack and create our first SLO. So I'm going to be using here a custom KQL, custom type of SLO. I'm going to select my serverless index here, and I'm going to put in the query and how the SLOs work within the transform framework, that you need to define a good query and a total query. So this is what I'm doing in the demo. I will select the partition by, here I will use, for example, the project ID. And you can play here around with a percentile, with a window, with a rolling window. Yeah, and also you can tag it as you wish. So that'll be like really useful later if you want to, check it by team or by project, whatever you want. I like to tag all my SLOs, it's easier to find. Right, so we'll create the SLO. So let's see what happens next. Right, just immediately after, I can go ahead and create also the burn rate alert. Obviously, I can create it later in the Kibana alerting, but it just saves time to do it here. I have the 4 periods, the windows that I mentioned before, and I can integrate it with whatever connector I want to. Right, so both of these are being created right now. I'm checking exactly to see where's my definition. Here we go. So it's one definition, but multiple instances because I grouped it by, a project ID. And I could go ahead and, if I know my project ID, I can specifically look at that project ID and start, playing with it, troubleshooting, and viewing the history here. Also, another cool feature is that I can add the SLOs and the burn rate alerts within a dashboard. So if you want to, share some information with other teams, or you want to have like a weekly meeting, then you could look at the specific dashboard for your service. So yeah, this is just basically goes through the workflow a little bit more. I'll let it play because I want to show you another feature afterwards. Right, and the same, you can tag it, and once you tag it, it's easier to find, right? Okay. Right, so the next part I wanted to show, we'll start this in a minute, it was the API part that I was mentioning it, that, for example, you want to use just APIs, you can go ahead and use only APIs. It's also like a slightly bit better for troubleshooting. So in the dev tools, in the console, you can go ahead and get, I want to see like how many transforms or how many SLOs I have in production, then use this because it's a lot faster and better. And you have all the information, like all the fields, the filters within that definition. You can catch the ID of your transform or your SLO, and then with that, you can query it to get more information on a specific transform or SLO. So yeah, that's, in my opinion, it's a lot better if you're like, they're debugging something and it's easier to use. You can reset, you can update, etc. Like, all the major APIs that are there. Right, so in essence, like trying to recap a bit what happened until now, the SLOs, like in the case of Elastic, have been created with the objective to be used with large entities, right, with large organizations. They are aimed to scale in that sense because of the transform, because of that architecture I showed you previously. They are used in that sense to scale with multi-clusters, multiple regions. So that's like the definite use case for them. Obviously, they can be used for smaller or medium organizations. That's not a problem. And it's a very, very good feature to start collaborating with other teams, developers, other engineering teams, project managers, etc. And they can be, like you've seen in the demo, very easily integrated with all the observability stack. So you can have, like the dashboards, APM data, latency, you can get the logs, you can start using the burn rate alerts. So they're all packed in the observability stack. And also with the APIs, you can manage them. So it's focused to be a configuration as code. Yeah, well, what I wanted to say, like from my side, is like I've been using SLOs also with the Elastic AI Assistant. So right now is gonna be a bit more like, let's say, customized. Oh, sorry, that always happens. Okay, so yeah, so it's a lot easier to. What I wanted to say is that. With the Elastic AI Assistant, right now, because of the workflow of the LLMs that we are using, it's, I don't know, even for creating an SLO, you can go ahead and create an SLO with the Elastic AI Assistant. So what we are doing, I'm going to keep adding a bit more features within the SLO. We're going to integrate it a lot more with other parts. We're going to use also a federated type of SLO. That means that you don't need to go, for example, in each region and create your SLO. You can have all the SLOs from all however many regions you are using. And another cool part will be the composite SLO, which means that you can take, I don't know, several definitions of SLOs and put them into one definition. These are like the next steps, the next developing steps for the project. My favorites, the one that we've been using a lot lately, at least from our side as SREs, are like the custom KQL, the one that I showed you in the demo. Why? Because it's permits to play around with the queries, with the definition. Also the APM latency and availability are very important in the incident management. So we've been using that a lot. And also we've been integrating them with Terraform. And that's also like something that has been successful. Right, so pretty much that's it. I wanted to share some resources that are available, like I said, in the slides. And if you have any questions, you can also use the feedback QR that I left there, so you can use that, or just use the channel. Thank you very much, and thank you for having me.
All right, got time for some questions if we have them. We got one right here.
On the primary alerting table, there are at least 12 tunable numbers, which might be a little bit too complex and confusing for as the owner and guys. So send those numbers, like, for example, as the owner who just wants to set up alerting policies, and there are so many numbers, and it's like.
Yeah, do you mean like in this table or in the demo? In the demo. Yeah, it's the same. Like I said, they were thought by default to have like 4 type of severities. I mean, this type of calculation is also available online. It's not something that Elastic developed. It's something like based on the normal definition of a burn rate alert. In the UI that you've seen, you can actually not use all of them if you want to. You can actually, once you deploy these, let's say via APIs, you can actually take some of that definition away. We are also using, let's say, slightly less, aggressive type of definition of burn rate alerts, just not to, constantly be fatigued by alerting. So we use just low and critical, and for us it's enough. So yeah, like I said, it's very customizable according to the notification strategy that you want to use. But yeah, I think the whole idea was to have the whole lot available than less, and then you can work towards less if you want to. Yeah.
Awesome. Any other questions? Up top. There. Oh, we got one right here.
A lot of the examples you have are time-based SLOs or time slice-based SLOs. Does this support event or occurrence-based SLOs? And if so, what is like the current rate calculation?
Does it support? I'm sorry, I didn't hear the
Event-based.
Event-based. Yeah. Does it support event-based SLOs?
Yeah, I think I already. Yeah, I don't think it supports event-based at the moment. Yeah, it's something that I could check definitely. So yeah, thank you.
Open a poll request. Poll request accepted. That's the joke. All right. Any other questions? There's one over here. Great.
I got 2 questions. First off, did you say you were using the SLO spec?
We're
Yeah.
using SLO spec. Yeah.
Yeah, exactly. Yeah, exactly. It was you.
Thank you for using it. Second question, I think you might go a little bit more to the question before about event or occurrence-based SLOs or time-based ones. When do you feel like in the situation when you use which ones?
When to use event-based or the other kind of SLO that I just forgot.
Yeah,
Time slices.
Time slices. Thank you.
Yeah, well, well, to be honest, it depends on the use case. Like you've seen, in my particular experience, I haven't used the times, well, neither, because in what we need is like something really, really, particular to our projects. So we haven't been using that at all, but it really depends on the, I don't know, on the use case that you want. Yeah, I don't have something like a use case to prescribe right now, but yeah, I mean, my limited experience in that regard is that I haven't used that in my specific project.
All right, anything else? I think we got them all. All right, let's give another big round of applause to Diana.